Everyone, myself Deepak Shah from New Catholic Mission School Java, and today's video is for class 12th chapter 7 integrals. Okay, so today's topic is definite integral. What is the meaning of definite integral? Definite integral means in this type of questions function have definite value, just like if the function is fx from a to b, then we write this function as fx dx and limit a to b. These are the limits. This is lower limit and this is upper limit. So, if we solve this fx, then integration of this fx is capital Fx and the limit is a to b. So, we put the value of upper limit first minus lower limit. This is the procedure of finding definite integrals when the function has limits a to b. Okay. And in this type of functions, after solving the question, we get definite answer. Therefore, this is called definite integrals and there is no constant term. So, we cannot use constant c in this type of questions. So, exercise 7.9, question number 1. Exercise 7.9, question number 1, limit -1 to 1 x plus 1 dx. This is the function and -1 to 1 is the limit of this function. So, first we integrate the function. So, integration of x is x square by 2 plus integration of 1 is x. So, this is the integration. Now, we put limits. So, first we put upper limit and then we put lower limit. So, upper limit means 1 square by 2 plus 1, this is upper limit in both this x, minus lower limit. So, lower limit is -1. So, -1 square by 2 plus -1. Okay. So, it is 1 by 2 plus 1 minus, this is also 1 by 2 minus 1. So, 1 by 2 plus 1 minus 1 by 2 plus 1, this 2 cancel, 2 is the answer. So, this is the procedure of definite integrals. Then question number 5, 0 to pi by 2 cos 2x dx. This function is trigonometric function. So, we know that integration of cos 2x is sin 2x and integration of 2x is 1 by 2. So, it is sin 2x by 2, limit 0 to pi by 2. We write it as 1 by 2 sin 2x 0 to pi by 2. Now, we put upper limit as pi by 2 minus lower limit. So, 1 by 2, this 2 cancel. So, sin pi minus sin 0, value of sin pi is 0 and sin 0 is also 0, then the answer is 0. Okay. Next question, question number 9. Question number 9 is integration 1 upon under root 1 minus x square dx, limit is 0 to 1. We know that 1 upon under root 1 minus x square dx is the integration of this function is sine inverse x. So, we write it as sine inverse x from 0 to 1, upper limit, it means sine inverse 1 minus lower limit sine inverse 0. We know that value of sine inverse 1 is pi by 2 minus 0. So, the answer is pi by 2. Next question is question number 13. Integration 2 to 3 x upon x square plus 1 dx. Okay. So, in this type of questions we substitute this value. First we put x square plus 1 equals to t. Okay. So, let t equals to x square plus 1, differentiate it, differentiate with respect to x. So, we get dt by dx equals to 2x plus 0, or dt by 2 equals to x dx. So, we have numerator x dx, at the place of x dx we put dt by 2. So, 1 by 2 dt, and in denominator we write t. Why? Because x square plus 1 equals to t. But if we change this function in the form of t, then we also change the limits in t. So, how we change the limits? We put x as 2, so we get value of t as 5, and if we put x as 3, so we get the value of t as 10. So, now the limits of t will be 5 and 10. Okay. Now, we know that integration of dt by t is log t, and the limit is 5 to 10. So, first we put upper limit as log 10 minus log 5, or we write it as log 10 upon 5. So, the answer will be 1 by 2 log 2. This is the answer of question number 13. Okay. Now, question number 15, exercise 7.9, question number 15. The question is integration x e to the power x square dx, and the limit is 0 to 1. Okay. So, first we put x square equals to t, take t is equals to x square, differentiate with respect to x. So, dt by dx equals to 2x, or dt by 2 equals to x dx, here x and dx. Okay. So, we write x dx as t dt, and this function is e to the power t. Also the limit, now we also change the limit. First we put x as 0, so the value of t is 0, and if we put x as 1, so the value is 1. So, now the limit will be 0 to 1. Integration of e to the power t is e to the power t, limit 0 to 1. We put e to the power 1 minus e to the power 0. Value of e to the power 1 is e, and e to the power 0 equals to 1. So, the answer is e minus 1. Now, next question is question number 17. Question number 17 is 0 to pi by 4 2 sec square x plus x cube plus 2x dx plus 2 into dx. This is the question. So, first, and the limit is pi by 4, 0 to pi by 4. So, first we separate it, 0 to pi by 4 dx plus integration 0 to pi by 4 x cube dx plus 2 integration 0 to pi by 4 dx. So, integration of sec square x is 10x, limit 0 to pi by 4, plus integration of x cube is x to the power 4 upon 4, 0 to pi by 4, plus 2 integration of dx is x, limit 0 to pi by 4. Now, we put limit, first upper limit as 10 pi by 4 minus lower limit 10 0, plus 1 by 4 common, and we put pi by 4 to the power 4 minus 0, plus 2 into pi by 4 minus 0. We know that value of tan pi by 4 is 1, tan 45 degree is 1 and tan 0 is 0, plus 1 by 4, this is pi to the power 4 upon 4 to the power 4 plus 2 into pi by 4, this 2 cancel. So, the answer will be 2 plus pi to the power 4 upon 4 to the power 5 plus pi by 2. This is the answer of question number 17. Now, question number 19. Next question is question number 19. 6x plus 3 upon x square plus 4. 6x plus 3 upon x square plus 4 dx. This is the question and limits are 0 to 2. So, first we separate it and write this function as 6x upon x square plus 4 plus 3 dx upon x square plus 4. We write it as 3 0 to 2 2x upon x square plus 4 dx plus 3 dx upon x square plus 2 square. Okay. Now, take this x square plus 4 as t, x square plus 4 is equals to t. So, the differentiation of dt by dx equals to 2x or dt is equals to 2x dx. So, 3, this 2x dx equals to dt and denominator is t. Also, the limits will be changed and if we put t as 0, so 0 plus 4 means t is equals to 4 and if we put x as 2, so it is 2 square plus 4. So, value of t is equals to 8. So, the limits are 4 to 8, okay, plus 3. This is the formula of integration dx upon x square plus a square equals to 1 upon a tan inverse x upon a. So, here a means 2, tan inverse x upon 2, limits are 0 to 2. So, 0 to 2. Now, dt by t means log t and the limits are 4 to 8 plus 3 by 2 tan inverse upper limit 2 by 2 minus tan inverse 0 by 2. So, 3 log 8 upper limit minus lower limit log 8 minus log 4 plus 3 by 2, this is tan inverse 1 minus 0. So, 3 log 8 upon 4 log m minus log n is equals to log m upon n plus 3 by 2 and the value of tan inverse x is pi by 4. If we cut it, then we get 3 log 2 plus 3 pi by 8. This is the answer of question number 19 of this exercise. So, this is all about exercise 7.9. Now, exercise 7.10, substitution, integration by substitution, definite integrals by substitution method. So, exercise 7.10, question number 1. Evaluate the integrals in exercise 1 to 8 using substitution. So, by substituting the values of function, we solve it and after that we put the limits and we find the definite value of the integrals. Question number 1 is 0 to 1 x upon x square plus 1 dx. So, first we put x square plus 1 equals to t and differentiate it. So, dt by dx equals to 2x. So, dt by 2 is equals to x dx. So, the question will be dt by 2 upon t Now we change limits. If we put x equals to 0, then we get 0 plus 1 means value of t is 1, lower limit is 1. And if we put 1 as x, so 1 square plus 1, it means 2. So the upper limit is 2. Now integrate it, so we get log t limits 1 to 2, and upper limit means log 2 minus log 1. We know that value of log 1 is 0, so it is log 2. So 1 by 2 log 2 is the answer of this question number 1. Question number 3. Question number 3, 0 to 1, sine inverse 2x upon 1 plus x square dx. Okay. So this, if we put x as tan theta, then we get 2 tan theta upon 1 plus tan square theta, and this is the formula of sine 2 theta. So we take t tan theta as x. Okay. So differentiation of function with respect to x is dx upon d theta equals to sec square theta. So at the place of dx we write sec square theta d theta. Okay. And sine inverse 2 tan theta upon 1 plus tan square theta. Okay. And the limits are also changed. First we put x as 0, so tan theta equals to 0. We know that tan 0 equals to tan theta, so the value of lower limit is 0, and again we put x equals to 1, so 1 equals to tan theta, it means tan pi by 4 equals to tan theta, so the theta will be pi by 4, so the limit is pi by 4. So now 0 to pi by 4 sine inverse, this is the formula of sine 2 theta and sec square theta d theta. We know that sine inverse sine theta equals to theta, so sine inverse sine 2 theta is only 2 theta, sec square theta d theta. Okay. Now by integration by parts. First integration of second dx minus integration d by dx of first, integration of second dx whole dx. So we write it as 2 0 to pi by 4 theta sec square theta d theta, first and second. So first is theta, second is sec square theta. Integration by parts. Integration by parts. First integration of second d theta minus integration d by d theta of theta sec square theta d theta and whole d theta. Limits are 0 to pi by 4. So integration of sec square theta is tan theta minus differentiation of theta is 1 and this is tan theta 0 to pi by 4 to theta tan theta minus integration of tan theta is minus log cos theta 0 to pi by 4. So theta tan theta plus log cos theta 0 to pi by 4. Now we put the limits, lower limit and upper limit. So first upper limit pi by 4 tan pi by 4 minus plus log cos pi by 4 upper limit minus lower limit, means 0 tan 0 plus log cos 0. So pi by 4 tan pi by 4 is 1 plus log cos pi by 4 is root 1 by root 2 and this is 0. So 2 into pi by 4 plus 1 by 2 log root 1 by 2. So, pi by 2 plus 1 by 2 log 1 by root 2 is the answer. Okay. So, next question, question number 5 of this exercise 7.10, sin theta upon 1 plus cos square theta. If we put 1 plus cos square theta sin x upon 1 plus cos square x dx, limits are 0 to pi by 2. So, take cos x equals to t, dt by dx equals to minus sin x. So, minus dt equals to sin x dx minus this is dt upon 1 plus t square, and the limits are, if we put cos 0 then we get 1, value of cos 0 is 1, and if we put pi by 2, limit is pi by 2, so it is 0. So, 1 to 0. Now, 1 upon 1 plus t square is tan inverse t 1 to 0, upper limit tan inverse 0 minus tan inverse 1. So, tan inverse 0 is 0 minus pi by 4, the answer is pi by 4. Okay. So, this type of questions are in exercise 7.10. By substituting the values of x and t, you can easily get the answer, and after that you put the values of limits and you can get the answer. Okay. Thank you.